Hello, everyone. This is Leo Mora. I'm the host for Suntawk. Welcome. This is our 10th session, and today we're going to talk about a little bit of two things. First of all, let's so some of the rules. We want to raise the intellectual development of everyone. We want to attain wisdom, and with wisdom, we get the power. So, the topics for today are artificial intelligence and the history, and the effects today, and what everybody is talking about. And we're going to talk about space exploration, um, a little bit of history, and a little bit of what's going on with the US and China, and a little reference to my book, Interplanetary Species, and a little bit of ethics that surrounds artificial intelligence and space exploration. All right, so the history of artificial intelligence is fascinating, evolving concepts and technological advancements marked by periods of both exuberant optimism and stark disillusionment. Here's a summary. So, early foundations, pre 1950s. The roots of AI extend far back, with ancient myths and mechanical automata hinting of humanity's long held fascination with creating intelligent machines. In the early 20th century, foundational work in logic and computational, such as the Alan Turing's concept of the Turing machine, laid the theoretical groundwork for modern AI. The development of the first electronic computers in the 1940s provided the necessary hardware to begin exploring AI's potential. The birth, 1950s to 1960s. The term artificial intelligence was coined at the Dartmouth workshop in 1956, considered the official birth of the field. Early AI research focused on symbolic reasoning, problem solving, and natural language processing. Researchers like John McCarthy, Marvin Minsky, and Alan Newell made significant contributions, leading to optimistic predictions about AI's future. In the 1970s, despite initial enthusiasm, AI research faced significant challenges, including limitations in computing power and the complexity of the real world problems. Funding for AI projects dwindled, leading to periods known as AI winters, characterized by reduced research activity and public skepticism. However, research continued in specific areas, such as expert systems, which achieved some success in niche applications. In the 2000s and 2010, the availability of vast amounts of data and increased computing power fueled a resurgence of AI, particularly in the field of machine learning. Machine learning algorithms, which enable computers to learn from data without explicit programming, achieved significant breakthroughs in areas like image recognition and natural language processing. Deep learning, a subset of machine learning using artificial neural networks, emerged as a powerful technique, leading to remarkable advances in AI capabilities. 2020 to the present, AI has become increasingly integrated into various aspects of daily life, from virtual assistants and recommendation systems to autonomous vehicles and medical diagnostics. Large language models and generative AI have taken a very large role in mainstream media and everyday life. Ethical considerations such as bias, privacy, and potential impact of AI on employment have become increasingly important. The future of AI holds immense potential with ongoing research focused on achieving artificial general intelligence and addressing the ethical challenges associated with this transformative technology. In essence, AI's history is a story of persistent innovation punctuated by periods of both triumph and setback. Today, AI is rapidly evolving, promising to reshape industries and redefine the relationship between humans and machines. AI systems are now incredibly adept at analyzing and understanding images and videos. This has implications in self-driving cars, improved object detection and scene understanding for safer autonomous navigation, medical imaging. AI aids in diagnosing diseases, detecting anomalies, and assisting in surgical procedures. Surveillance and security, enhanced facial recognition, object tracking, and anomaly detection for improved security measures. AI in healthcare, personal medicine, tailoring treatments to individual patients based on their genetic makeup or medical history. Drug discovery, accelerating the process of finding new and more effective drugs. Disease prediction, identifying individuals at high risk of developing certain diseases. AI tools and technologies are becoming more accessible to developers and businesses thanks to open source frameworks, making AI development more accessible to a wider range of researchers and developers. Cloud-based AI systems providing easy access to powerful AI capabilities through cloud platforms. Okay, so a little bit example of using AI. So I use Gemini, and basically I'm going to tell it to look at a resume and write a summary of the attached resume. So it's going to create in this case, created a longer summary. So basically here in Gemini you can say, well, attach an image, attach a file, or a file from Drive, or make a canvas, or talk to Gemini. So I can say write a summary of 3,000 words about the Roman Empire. So I love artificial intelligence, and I just use it for everything. And it's amazing. I mean, it's not 100% perfect, but it just gives you ideas and saves you so much time. I mean, look at this. If I had to research this, it would take me forever to come with a summary of the Roman Empire. So I even told AI to analyze Excel files and convert my daughter's resume to a intern resume, and it did it beautifully. I mean, it was like 99%. I just had to correct some things, but it's amazing. It's amazing. So so I recommend it. So basically, we have 3 AI engines. Well, 4 now. We have ChatGPT, Gemini, Copilot and Microsoft and DeepSeek, the Chinese version. So yeah, so this is awesome. All right, so let's jump into the next topic, which is space exploration. So a little bit of history here. In the mid 20th century, witnessed the birth of a space age driven by the intense competition between United States and the Soviet Union. In 1957, the Soviet Union's launch of Sputnik 1, the first artificial satellite, marked a pivotal moment signaling humans' entry into the cosmos. This was quickly followed by the launch of Sputnik 2, carrying the first living creature, the dog Laika, into orbit. The United States responded with Explorer 1 in 1958, initiating a period of rapid advancements in rocket technology and spaceflight. In 1961 saw another landmark achievement. Yuri Gagarin of the Soviet Union became the first human to orbit Earth, followed shortly after by Alan Shepard's suborbital flight for the United States. The race to the moon. President John F. Kennedy's bold declaration to land a man on the moon by the end of the decade, 1960s decade, ignited a fierce race that captivated the world. The Apollo program, culminating in the historic Apollo 11 mission in 1969, achieved this goal with Neil Armstrong and Buzz Aldrin becoming the first humans to set foot on the lunar surface. The Apollo missions provided invaluable scientific data and lunar examples, expanding our understanding of the moon's composition and history. Beyond the moon, unmanned probes ventured to explore the solar system. The Mariner and the Voyager programs provided close-up views of Mars and Venus, revealing the diverse landscapes and atmospheric conditions. The Voyager missions, launched in the 1970s, embarked on the grand tour of the outer planets, sending back stunning images and data from Jupiter, Saturn, Uranus, and Neptune. The Hubble Space Telescope, launched in 1990, revolutionized astronomy, providing breathtaking images of distant galaxies and nebulae. The construction of the International Space Station marked a new era of international cooperation in space. Robotic missions continue to explore Mars, seeking evidence of past or present life and other bodies in our solar system. Private companies are increasingly playing a role in space exploration, with initiatives focused on space tourism and commercial spaceflight. The James Webb Space Telescope has started giving humanity incredible new views into deep space. Future plans include crew missions to Mars and continued explorations of celestial bodies. The search for exoplanets and extraterrestrial life is also a very large goal of modern space exploration. In essence, space exploration has transformed our understanding of the universe and our place within it. It continues to inspire generations and drive technological innovation, pushing the boundaries of human knowledge and capability. So the James Webb Telescope, has captured so many images, and scientists are now saying that everything that the theories that they had was like wrong, and that the telescope is just showing so much knowledge. The OSIRIS-REx, the spacecraft that the first American attempt to bring back a sample from an asteroid. It went to the asteroid Bennu, which could be a threat to Earth in the future. The Nanograph Observatory detects waves that were related to dark matter, gamma rays from the pulsar Vela supernova remnant, The high energy stereoscopic system has in Namibia detected gamma rays that are way above the usual GeV cutoff. This implies that our understanding of how electrons are accelerated in strong magnetic fields is incomplete. Researchers found that women astronauts recover quicker from space flight conditions after returning to Earth than men did. In 2024, astronomers made many discoveries in space, including detection of distant black hole merger, a new planet, and a binary star near the Milky Way black hole. So this shows the evolution of the rockets that we've been using, the Space Shuttle, the Falcon Heavy, the SLS, Block 1, the Saturn V, and the current Starship. Although impressive, I think it has more problems than what it solves. I mean, you have these gigantic rockets to just get out of Earth's gravity. So the problem with these, as what happened with the Challenger and the Columbia, is that any issue, any minor issue, it's a big explosion and everybody tend to die. So it's very dangerous to fly these rockets, and SpaceX just wants to make bigger and bigger rockets. So on the other hand, we already know, or if you didn't know, we already know about certain technologies that can produce anti-gravity. So one problem is getting out of Earth's gravity with anti-gravity. And the second problem is once you are in space, you need to generate gravity because our bodies are not designed for zero gravity. Digestion and blood and the heart and the blood, and I mean it's just a mess. So those are the two problems we need to solve. So there are three technologies that deal with anti-gravity. The first one is element 115, which basically if you bombard element 115, it creates a anti-gravity field around the ship. So what I mean by anti-gravity is that field that surrounds you with anti-gravity eliminates the physical laws that we are accustomed to. So basically you can travel at incredible speeds and you can do things that no plane and nothing that we know currently can do. The second technology is using mercury with counter-rotating cylinders. Oh, and this is a patent from the Air Force with a anti-gravity plane. So you can see the circle in the middle. So that's the anti-gravity engine. And here is the patent. So they patented this not long ago. So currently it's super secret, but I mean, we will get there. And the other technology that creates anti-gravity is liquid nitrogen on a superconducting ceramic ring. So you can create anti-gravity that way as well. This is a lot safer than this here at the left side. This is a lot safer, a lot faster, and it will take us anywhere in the solar system. So news from NASA. So NASA, this is the U.S. So they found a super Earth planet that orbits 137 light years away. The planet is 1.5 times wider than Earth, and it's in the star's habitable zone, which means it could have liquid water on its surface. They found an exoplanet with water molecules in the atmosphere about 97 light years away from Earth. They found little red dots that appear in the sky discovered by the James Webb telescope. The James Webb found disks around stars could live longer than previously thought, which could help planets grow larger. NASA's Lucy spacecraft discovered a mini moon orbiting asteroid Dinkinesh. NASA returned a sealed capsule containing a carbon-rich soil sample from the asteroid's Bennu surface. And NASA is also involved in the building a spacecraft for NOAA's Geostationary Extended Observations satellite program, providing live coverage of the launch of NOAA's GEOIS mission and testing the performance of materials and devices in the International Space Station. Now, from China, I like China being involved in this because Russia kind of fell over and China is doing a lot of things. Let's take a look. China returned samples from the far side of the moon, which is the first time a sample of this part of the moon has been returned to Earth. China plans to launch Mars sample return mission called Tianwen-3 in late 2028. China plans to launch Tianwen-4 around 2030, which will include a solar-powered orbiter around Jupiter and radioisotope-powered spacecraft that will fly by Uranus. China plans to launch Suntawk Space Telescope in 2026 to study exoplanets, star formation, and galaxy evolution. China launched a spacecraft with a 3-person crew, including a country's first female space engineer. The crew conducted experiments and spacewalks at the Tiangong Space Station. They have their own space station. China is developing a long March 9 Super Heavy Lift launcher for major space infrastructure projects. China is developing the Long March 10 to launch crews, including crewed lunar landing missions. China's commercial space sector is expanding with firms outlining ambitious plans, and China's space program is working towards sending humans to the moon in 2030. So I wrote a book about interplanetary species. So basically, what I say is we need to educate 3 generations of kids into de-learning all the stuff that we do currently, like lack of trust. I mean, trust is number 1 for me. If there's no trust, there's nothing. Number 2 is envy. Number 3 is the smart ass syndrome. And number 4 is empathy. Those 4 are key to developing a new generation of people, of kids that with all the things that I teach about knowledge and wisdom can really evolve into higher consciousness and travel around the solar system without destroying it or for financial gain. What are the one of the 5 of the most famous space movies? We have 2001, Interstellar, The Martian, Apollo 13, and Gravity. Those are the ones that I like the most. So Thank you for watching, and see you on the next one.